So today we're going to start learning how to multiply and divide fractions. Multiply and divide. Well, you did this last year. So the rules from last year really don't change except for maybe the technique we use. Right? So I'll talk about that later. One of the things that's going to be different between the grade 8 questions and grade 9 questions is your questions are probably going to have a lot more negative signs than you're used to in grade 8. So our final answer is either going to be a positive number or it's going to be a negative number. And if it's negative, it only should have one sign. It shouldn't have lots of signs, right? So if we're multiplying stuff and we have lots of negatives, one of the things we need to do is combine those negatives to either a single positive number or a single negative number. And we use our multiplying rules and our dividing rules. And the way that worked is, hey, as long as the signs were the same, there were two positives or two negatives, and you're multiplying them, you ended up with a positive number. And the same rule existed in the dividing world. If you divided a positive and a positive, you divided a negative and a negative, your answer was positive. However, if the signs were different, then you ended up with a negative number, right? And basically, we sort of, that works well if we only have two signs, but the logic we're using is two negatives can pair up to make a positive number. Right? So we count our negatives. If we have an even amount of negatives, our answer is going to be positive, because all those negatives can pair up. And we sort of talk about this with exponents as well. Right? And if you have an odd number of negatives, they can't all pair up, and the final answer is going to be negative. So let's put this to practice here. So looking at something like this. In the first one here, there's only one negative sign. So our answer just stays the same, right? There's nothing to clean up. All right. How about the one on the top right? Is the final answer positive or negative? Positive, because two negatives pair up, right? End up with a positive 1/2. This middle one over here, positive or negative? Positive. Negative. Right? I heard a positive and a negative. We have two negatives that can pair up. Right? And it doesn't matter which ones you pick. Two of them can pair up, and you have one negative left over. Right? So the answer is going to be negative. So where do we put that negative sign? Do we put it at the bottom two? Do we put the top one? Do we put it out front? Where do we put that negative sign? Joban? My default answer to you is technically it doesn't matter where the negative sign goes, but it's best to put it out top or out front. I'm going to say put it up top. Right? That's just where you're going to make less mistakes. Unless you have a mixed number. Then you go out front. Okay. This one over here. Is it positive or negative? Positive. Positive. You have two negative signs. This one and this one cancel each other out, and you have the positive. How about this one over here? Positive. Positive. You have a negative here and a negative here. They cancel each other out and to make it positive. All right? So things are going to look a lot more confusing because all these negative signs are all over the place. One of the first things I want you to do is when you're multiplying, count the negatives and figure out if the answer is positive or negative. And it makes it cleaner. All right? So like for example, all right? On this question here, before we multiply these things, right? We have how many negative signs? 2. They're going to cancel each other out. So our final answer is going to be positive. So at the end, I'm not worrying about the sign. I've already decided in my mind that this is going to be a positive answer. So I know over here on step number 2, I said find the positive pairs with the negatives. Right? I think you should do it right away. I think it makes it a little bit easier. All right, positive pairs. Okay, so now, if you want to multiply fractions together, the rule from last year was you multiply the tops together. That gives you the number on the top. So you have 2 times 6 is 12. You multiply the bottoms together. 3 times 7 is 21. Right? then you get your answer and you make it smaller. You go, okay, what can fit in the top and the bottom to make this smaller? 12 over 21. Is there a number that can divide to make it smaller?
3.
3. So we went like this. Divide by 3. Divide by 3. You end up with 12 divided by 3 is 4. 21 divided by 3 is 7. All right. So there is nothing wrong with this method that your teacher last year taught you. All right. And if you this year, if you really, really like that method and you don't want to learn what Mr. Dhaliwal's teaching you, and you want to stick with what your grade 8 teacher taught you, you can do it. But the problem is it's not efficient. Right? For example, in our morning question, the stuff at the bottom, our warm-up, those were the hard questions because the numbers got bigger. So it became hard to simplify. Right? Figure out what fit into those things. If I give you a question like this, let's look at this. And this is the bottom right-hand corner. We have 3 fractions being multiplied. First of all, if we do the same thing, is the answer positive or negative for this one?
Positive.
Positive. We have 4 negatives. So this negative pairs up with this one, and these ones pair up and cancel each other out, so the answer is positive. Then, if you did it, the method we did in grade 8 is you multiply all the tops together. You go like this. Let's go here, grab my calculator. So on the top, I have 16 times 20 times 15, 4,800 on the top. Then I multiply the bottoms together. And so I have 30 times 48 times 10, and I get 14,400. Right? And then you start simplifying. So if I was marking your stuff in grade 8, this would be like a 2-mark question. I'd give you 1 mark for coming up to the top and the bottom, and there'd be 2 full marks if you could reduce it to simplest terms. But that's a huge number. That's difficult to make smaller, right? And if you only made it halfway to the lowest state, I'd give you like 1.5 out of 2. But I'm going to teach you a different method. And if you're in my grade 8 class last year, there's a bunch of you guys in my grade 8 class last year, it's the same method we learned last year. So here's the thing. Instead of saving all the simplifying to do at the very end, we're not going to do it at the end. We're going to do it at the beginning. We're going to simplify or reduce the fractions before we multiply. We're going to reduce or simplify, whatever the phrase you like, the fractions before we multiply. The benefit of that is the numbers are smaller and so much easier to simplify. So I'll show you how it works. So looking at this question here, exact same question we just did, all right? And we're going to use it the other method. We're going to do the same thing. We're going to cancel out the negatives. So the 2 negatives cancel out. And how do we simplify first? Now, when we're simplifying, what we do is we look at the top and the bottom and we figure out what number can divide a top and a bottom to make it smaller. And we use the exact same rule here. Is there any number that can fit into 2 and 3 to make it smaller? No, that's the smallest it can get. Is there any number that can go into 6 and 7 to make it smaller? No, 3 doesn't fit into 7. It fits into 6. So there's nothing we can go smaller there. So when we're trying to make it smaller, we compare tops to bottom on this fraction and this fraction. But we also look in the diagonal direction as well. And we go this way. Is there a number that can divide 6 and 3?
2.
2 can't fit into 3. But there is a number that can fit into 6 and 3.
3.
3. So what we do is we go, okay, I'm going to divide those 2. I know they're not on the same fraction, but they're multiplying. So I can do the top and the bottom. So I go like this. Instead of showing the dividing sign, because that takes a lot of space, we go, okay, I'm going to cross this one off, and I'm going to cross this one off. And I'm going to divide both of those by 3. And I go, okay, 3 divided by 3, I have a leftover 1. And you go, 6 divided by 3, I have a leftover 2. Right? And you go, okay. Now you go look the other direction. Look in this direction. 2 and 7. Can you make that smaller? No, those are both prime numbers as small as they can get. So now, once you simplified all tops and all bottoms, we do the same thing. We multiply the tops together. 2 times 2, we get 4. Multiply the bottoms together. 1 times 7 is 7. So the same answer, just a different strategy. Now, it probably seems like a lot of extra work and weird to do it this way, especially on a question like this when the numbers were small. But as the questions get bigger, this technique is so much easier to use. All right? And that's what we're going to practice. So when we're looking, you want to compare top to bottom. All right, so I'm going to draw some fractions here. So if I have one fraction here and a fraction here, there's a little line here, you want to compare the top and bottom this way. You want to compare the top and bottom this way. And you want to compare the top and bottom at a diagonal as well. Right? And this usually works so well for students. Right? And where they go wrong is sometimes they may try to make 2 tops small or 2 bottoms small. No, the pairing has to be a top versus a bottom. Right? Just like we simplify at the end. It's always a top divided by a bottom. So let's look at some more questions here. Let's look at this one here. All right? So we're going to use this method here. So looking at this, first thing is this going to be a positive fraction or a negative fraction as our final answer?
Positive. Negative.
Negative. We only have one negative sign. So it's going to be negative. So I'm just going to put the negative down first. So I'm not going to worry about the signs anymore. Right? I know the answer is going to be negative. Now, I look at the tops and the bottoms and say, is there anything that can make smaller? Here. Yes, there is. What do you guys see? The 2 3s. They're exactly the same. They can be each divided by 3. So 3 divided by 3 is 1. 3 divided by 3 is 1. You can divide the 4 and the 2 by 2. Divide both of these by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. You don't need to write down the little divide bys. That gets kind of messy. Just do little slashes. And since we get all down to 1s, that's about as small as we can get. So what we have left on the top is 1 times 1, which is a 1. And on the bottom, we have a 2 times 1, which is a 2. 1 over 2. Okay? Let's try it again with slightly bigger numbers. Looking at this one, is the final answer negative or positive? Negative. Okay. Now, compare tops and bottoms. Is there anything you can divide to make smaller? Have a look at it, Nick. You're distracted. All right? Is there any pairs that you can divide up? You see anything, right? Is there anything you can divide to make it smaller? There should be. I see even numbers all over.
6.
Into which numbers?
48 and 60.
There's no 48. Or 42 and 60. Yeah. So 6 can divide both of these. Right? 6 can fit into both of these. So 42 divided by 6 is 7. And 60 divided by 6 is 10. Okay. Any other ones? Ashalia. By which number? By 8. So you can divide both of these by 8. And if you're not sure, remember, you can still use your calculator, right? Okay, I'm going to divide both of these by 8. I go 64 divided by 8 is 8. And I have the other number is 96 divided by 8 is 12. So I got 8 and 12 left over. 8 here and 12 here. So here's the thing. Once you've crossed off a number, this number can't be used again. But the numbers you wrote up above or down below, maybe they can still be made smaller. Is there any other pairs of numbers that you can make smaller? Joban?
8 and 12 by 4.
8 and 12 can be divided by 4. Right? So divide, cross them off as pairs. Divide both of them by 4. So 8 divided by 4 is 2, and 12 divided by 4 is 3. Is there any other pairs of numbers? 2 and 10. Those are both even numbers. And you can divide it by 2. And you can go, okay, divide this by 2, divide this by 2. So 2 divided by 2 is 1. And 10 divided by 2 is 5. Okay. It's time to check. Is there any other pairs?
No.
No, that's it. So we multiply the tops and the bottoms together. So 1 times 7 is left on the top, which is a 7. And on the bottom, we have a 3 times 5 left over, which is 15. Right? And yeah, this is kind of messy. You're kind of all over the place. There's no set one way of doing this because you can pick any pair of numbers to make it smaller. But that, I think, is so much easier than trying to simplify 64 times 42, getting this number as your top, and 96 times 60, getting that number as your denominator, and trying to simplify that. That's a pain. All right? So this is the method that your grade 10 teacher will be using with you next year. And hopefully you can get comfortable with it and use it. Right? Sean, hopefully you're paying attention here, bud. All right? So we're going to look at this one here. And you're going to try to make it smaller. And I'm going to ask Sean for help. Is there any pairs of numbers? Now we have 3 fractions. The other ones only had 2. Right? As long as everything's multiplying, any top with any bottom. They don't have to be on the fraction right next to each other. Long as they're all multiplying. All right? Is there any pairs on the top and bottom that you can make smaller? Sean, do you see something? Anybody else? While Sean's thinking, do you see something that?
16 by 20, like where 20 is.
Oh, 16 and 20 you can't do because they're both on the tops. It has to be a top-bottom pair. Ashalia, do you see something? 15 and which one? 10. So you may have seen something else, but Ashalia saw 15 and 10. Okay, divide both of these by 5. So 15 divided by 5 is 3, and 10 divided by 5 is 2. Now, that's where her mind went. It's excellent. Where my mind went, it's like, hey, I know 10 and 20 fit into nicely each other, and I know 15 and 30 fit nicely in each other. Right? I could have done those two, but it depends on what you see. So there's no right way of doing this. So you just keep on working at these numbers and keep on making them smaller and smaller and smaller. Do you see something else, Ashalia? 20 and 30. What can those be divided by? Sorry? 10. 20 and 30 can be both divided by 10. So 20 divided by 10 is 2, and 30 divided by 10 is 3. Anything else?
16 and 48 can be divided by 8.
16 and 48 can be divided by 8. So 8 fits into 16 how many times?
Into 16 too.
2. 8 fits into 48 how many times?
6 times.
6 times. All right. Is there anything else that could be made smaller? Nick?
The 6 and the 2. And
Yeah, so now we have a 6 here, not the 2 on the bottom. We can pick any 2 on the top.
yeah.
So the purple 2 or the blue 2, which 2 would you like to prefer, Nick?
With,
Blue? Okay. They can be both divided by 2. So 6 divided by 2, we have 3. 2 divided by 2, we have 1. Anything else? Mio?
3 divided by 3.
Yeah. Okay, so we have a 3 on the top. We have the red 3 on the top. And which 3 do you want on the bottom?
The green one.
The green one. Right? So 3, oh, that one didn't work. 3 divided by 3 is 1. Anything else?
So 2 divided by 2.
2 divided by 2. We have a 2 on the top over here. Which color? I'll use blue. And a 2 on the bottom here. 2 divided by 2. 1. Anything else?
No.
No, that's it. Right? So on the top, we multiply all the tops together. 1 times 1 times 1. We end up with a 1. On the bottom, we multiply the bottoms together. 3 times 1 times 3 is 3. Answer 1 over 3. All right? Something different. A little bit messier than what you learned in grade 8, but I think it's a whole lot faster. Right? And a lot easier than trying to simplify 4,800 over 14,400. All right? Okay, so I'm going to let that sink in.